Hello, everyone. How are we doing? We get to start topic 4 today. Topic 4 is all about triangle congruence. So we have a lot of fun things that we get to talk about here. So we're just going to go ahead and get started because there's a lot to do, right? So today we're going to focus just on 4-1, which is just all about congruence. Are two things congruent? How can we tell? What does congruent mean? Things like that. Two objectives for today. The first objective says, by the end of this lesson, I will be able to relate congruence to rigid motions. So again, a reminder, rigid motions are those motions that move shapes, but they don't change the shape and they don't change the size. Okay, so you can reflect, you can rotate, you can translate, and those don't change the shape or the size. Okay, and then we're going to demonstrate that two figures are congruent by using one or more rigid motion to map one shape onto the other, meaning how can I move this shape and have it match up with this shape. So 4 new vocabulary terms today. They are congruent angles, congruent segments, congruence transformation, and then just congruent. Like, what does congruent mean? So we're going to turn to the very back of our topic 4 packet, and we're going to fill out these 4 terms so that we can go ahead and do 4-1 lesson. Okay, so here we are down at the terms page. Hopefully you found it. And we have those 4 terms to go over today, like I said. So the first one we're going to start with is congruent angles. These are angles that have the same measure, right? So if I have this angle, let's call it A, and then this angle, let's call it B. And if these two angles are the same, and I know they're the same because I just drew those little arcs on them, right? Then we can just say that angle A is congruent. So remember, congruent is the equal sign with the squiggly above it, okay? Angle B. So angle A is congruent to angle B. Similarly, congruent segments are segments that have the same measure. So if I have a shape, I can do better than that. So there's a shape, I'm going to call this AB. And we can call this EF. If these two line segments are the same length, they will have the tick mark, right? So I just drew the tick mark. So this tells me that line segment AB, and I know it's a line segment because I can draw a line above it, is congruent to line segment EF. So all this means is that two lines are congruent if they are the same length. Two angles are congruent if they have the same angle measure. So therefore, and I'm going to skip congruence transformation, therefore, congruent just means a shape that has all equal length and equal angle measures. So the shorter way that we say this is same shape, but not only the same shape, also the same size. Same shape and the same size. So let me see if I can draw this. So if I have a trapezoid of some sort, there's my trapezoid, and then I have another trapezoid. So let's say like A, B, C, D, and then E, what's an E, sorry, F, G, H. Okay, so if AB and EF are the same, and let's say that DC and HG are the same, and I know they're the same because I have 2 tick marks. And let's say that AD and BC and EH and FG are all the same. Okay, so I know that the four side lengths, the corresponding sides are congruent, meaning AB is congruent to EF, and DC is congruent to HG, and AD is congruent to BC, which is also congruent to EH and FG. So all the angle measures, all the side lengths are the same. And then these two angles are the same as these two angles. And then these two angles are the same as these two angles. Notice I drew a little tick mark through them to distinguish them from these guys. So since all of the angle measures line up and are the same as the other shape, and all the side lengths line up and are the same as the other shape, then I can say that trapezoid ABCD is congruent to trapezoid EFGH. And again, when we're proving the congruence, we don't have to draw all these tick marks and all these angle measures, but just to show you, okay? Now, a congruence transformation is a rigid motion, so a reflection, a translation, or a rotation, right? Those are the three that result in a figure that has congruent sides and angles, meaning I can do anything to a figure as long if I reflect it, if I translate it, or if I rotate it, the resulting figure will be congruent to the original figure. So if I have like a heart and I rotate this, that was actually a lot better than I thought it was going to be, right? These guys it's a congruence transformation, right? Because these two hearts are congruent. They're the same shape and they're the same size. Okay, so those are our definitions for this lesson. So we're going to go ahead and clear this. We're going to go back up to the top of the first page at 4-1, and we're going to actually get into the meat and potatoes, as they say, of this lesson. Okay, so here's 4-1 in example 1. It says, suppose that there is a rigid motion that maps one figure to another. So here I have reflected this shape over here, and then I've translated this shape down here. Why does that show that the two figures are congruent? So why does that show that A, B, C, D, E, F is congruent to L, K, J, I, H, G? Oh, sorry, wrong. G, H, I, J, K, L. That makes more sense. Okay, so what happens here when I reflect, do the side lengths change? Like this is 2 units, this is 2 units, right? This is 1 unit, this is 1 unit, 1 unit, 1 unit, and so on and so forth. And so the size of it hasn't changed, the shape of it hasn't changed, it's just reflected. So what happens in a rigid motion? So rigid motions preserves corresponding angles, not angles, side lengths, meaning the side lengths are the same, and angle measures. So that means the angle measures are the same. So if I reflect something, the sides don't change, the side lengths don't change, and the angles don't change. If I translate something, the side lengths don't change and the angles don't change. So in this case, the side lengths in GHIJKL did not change. Right? The side lengths are the same. Not only are the side lengths are the same, all my angles stayed right angles. They were currently right angles, and then they stayed right angles. So the angle measures did not change. So the side lengths did not change, and the angle measures did not change. Therefore, they are congruent. Okay, here it says a 90-degree rotation around the origin maps triangle PQR. So triangle PQR is rotated 90 degrees, and now it's called triangle LMN. Are these triangles congruent? Well, a rotation is a rigid motion, right? When I rotate something, the side lengths don't change and the angles don't change. So if the sides don't change and the angles don't change, are the two shapes congruent? And hopefully we said yes. Okay, or we're thinking yes. Okay, and it does say explain. So I'm going to say rotation is a rigid motion. So since rotation is a rigid motion, we can say so size and shape are the same. Right? So size and shape are the same. So triangle PQR is congruent to triangle LMN. So even without drawing it, even if without knowing what the triangles look like, it doesn't matter. I know that they are the same because if I rotate something, it does not change. Okay, so let's keep looking here. Okay, so congruence, we just talked about it a little bit, but figures that have the same size and shape are said to be congruent. Okay, so if they are the same size, same shape, they are congruent. Can't say it enough. Okay, so we're going to look at a couple more examples here on trying to figure out what the actual transformation is. How did we get from one shape to the other? Okay, so example 2 here says, given triangle XYZ, so this one was given to me, how did I get to this one? Okay, how did I get to this one? And there's a lot of different ways that you can do this. Okay, so just because I'm going to do it one way doesn't necessarily mean that's the only way to do it. Okay, so I just want to make that super clear. So I'm trying to figure out what did I do to go from XYZ to ABC. So the first thing that I see is that I want this tip to be facing down. So I either need to reflect it and then reflect it again or rotate it. So what I'm going to do is I'm going to rotate it, and I'm going to rotate it 180 degrees around Z. And what that will do, is this gives me this triangle. So once I rotate it, I have that triangle. But that triangle does not line up with this triangle. So now what I can do is just slide it, right? I can slide it over 1, 2, 3 units. I want this point to be here. So I'm going to slide it to the right 3 units. So I'm going to combine this with a translation of 3 units to the right, so positive 3, and 0 units up or down. So that transfers it over so that it lines up with this triangle now. And that's what I'm looking for. So not only that, then you usually do, okay, so I figured out the transformation. Now I can say triangle XYZ. So it's saying if I do these two things, to triangle XYZ, I'm going to get triangle ABC. So that's the rest of it, is just saying once you figure out what you've done, you say, which triangle are you doing that to, and what do you get in the end? So what it comes down to is, if I want to go from XYZ to ABC, I'm going to rotate 180 degrees around Z. Then I'm going to move it to the right 3 units, and that will get it to line up. So let's look at these two triads. So I want you guys to actually try this. I don't care if you mess up. There's a lot of different ways to do it. So if you do it and you're like, I'm not sure if that, works or whatever, I'm more than happy to check it for you, because there's always more than one way to do these, okay? But you're given triangle GHJ, and you're trying to get it to KLM. So what composition of rigid motions can do that? And there's lots of different ways, and I want you to really try it. And if you mess up, no big deal, but put some effort in. And then part B is saying, what's another way, right? Because there's always more than one. So see if you can find more than one way. So hit pause on this video, and then when you're ready to review, go ahead and hit play. Okay, so let's go ahead and review this. Again, multiple ways that you could be doing this, okay? So maybe this is one way that you did it. What I saw first was that I could translate GHJ, so this top triangle. And if I translate it to the right 2 units and down 10 units, I go right 2, down 10, and so that puts J there. And right 2 and down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's H, there's J, right? And then down or over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So something like that. So that would be the first thing that I see. Oops. Go. And then from there, and I'm going to change colors so we can see the difference here. From there, I can rotate this 180 degrees. If I rotate it 180 degrees, it will line up on that triangle. So remember that rotates are lowercase r, and I say how many degrees I'm rotating, which in this case is 180. And then I also have to say what point. So I'm going to rotate around point M, right? Because that is a point on the graph, right here, M. So then that would get me this triangle here. So that's one way that you could have done it. That is not the only way. There's actually lots of different ways, okay? Okay, so I'm going to get rid of this. And then part B says, what is another way that you could do it? So maybe this is a way that you looked at it. I see that I could, so the halfway mark, let's see, between J and M is right here at x equals 1. So if I reflect this triangle, so I'm going to reflect over the line x equals 1. And what that does is that gives me, this is now J prime. What is this name? 5. So this is now H prime. Okay, and then this is G prime. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Oh, can't count. That's G prime. I was gonna say that doesn't look right. 2, 3, 4. Oh, you guys just, I'm out of it. Okay, there's H prime. There we go. That looks better. Okay. So then here would be that secondary triangle. Okay. And then from here, so again, I'm going to switch colors so I can combine this. I could also reflect over this line. And if I reflect over this line, J is going to come down here to M, H is going to come down here to L, and K is going to, or G is going to stay there at K. So I can also then reflect over the line. And this, since it's horizontal, this is the equation y equals 2. -2, sorry. Y equals -2. So that's another way that you could have done it, okay? Keep in mind that you do the one in red, so we do the one on the right first, and then the one on the left. There are other ways to do this. So if you did it a different way and you're not sure, just reach out and we can check your work. Okay, one more try it here for you. It says, what is the composition of rigid motions that will map A, B, C onto A prime, B prime, C prime? So here, I just want B to go to B prime, and C to go to C prime, and A to go to A prime. Well, do you notice how it's the orientation is the same? It has not been reflected or rotated. So because of that, we're kind of lucky. It's just a slide. It's just a translation. So now I just have to figure out how far did it translate, right? So go ahead and do this real quick. Figure out how far did it translate, and then we'll check our work. Okay, so let's look here. To go from B to B prime, let's get rid of my arrow. Right, to go from B to B prime, I go left 1, 2, 3, 4. So since I go to the left 4, that's going to be -4. And then I go down 1. So that's going to be -1. And that's it. And that works for all the points, right? If I would do A to A prime, 1, 2, 3, 4, down 1, right? Or C to C prime, same thing. Okay. Okay, let's move on. Let us know if you're having trouble on any of this so that we can help you, but otherwise we're going to keep going. It says, given triangle ABC, triangle EFG, and triangle JKL, which triangles are congruent? So I want to know which triangles are the same. So there's lots of, I guess, different ways that we can do this. But I'm just going to start by picking a triangle and kind of counting what we call slope triangles. Okay, so I'm going to go the shortest side, B to C. So this is 1, 2, 3 units by 1 unit, right, to go from B to C. This one is 1 unit by 3 units, so that's the same length. This one is 3 units by 2 units. So that one is not the same as the others. So now we just need to see, are these two triangles congruent? We've already eliminated EFG. So now let's check other points on this triangle, right? From A to B, I go 1, 2, 3, 4, 1. From K to J, I go 1, 2, 3, 4, 1. So that's still good. So far, 2 of the sides are the same and looking good. And then the last one is A to C. So I go 1, 2, 3, 4, 1, 2, 3, 4, 5. And from L to J, I go 1, 2, 3, 4, 5, 1, 2, 3, 4. So since my ratios are all the same, I can say that triangle ABC is congruent to triangle JKL. Okay, so just finding those shapes that are the same. So we're going to try some of these. So I want you to try this one. It's asking you here is A, B, C, D, E, so right here, congruent to JKLMN, this guy right here? Are these congruent? If they are, tell me what the composition of transformations is, right? Tell me, do I reflect it and then rotate it, or reflect it and reflect it, or translate it and reflect, right? Tell me how I get A, B, C, D, E onto J, K, L, M, N. If they are not congruent, tell me why. And you're going to do this for A, and you're going to do it for B. So go ahead, hit pause on the video, and then when you're ready, we're going to go ahead and hit play and go over it. Okay, let's look at A here. And I'm curious, are these two shapes the same? So I just start counting, right? My shortest side here is down 1 over 2. My shortest side here is over 2 up 2. So automatically, these sides are not the same, right? I don't have any sides on A, B, C, D, E that are over 2 up 2, right? This one's over 3 up 2. This is 3, 1, and so on and so forth. So these two shapes are not congruent because their side lengths are not equal. Okay, so you can say no, because it's asking, are they congruent? No, and then it says explain. So not all side lengths and angles are the same. Uh-oh, my dogs. Okay, so because all the side lengths are not the same on A, then they are not congruent. For B, I'm interested, so this is out of the picture now. I'm interested in A, B, C, D, E, and V, W, X, Y, and Z. So if I go through and I start counting, right, this one had a ratio of 1 to 2. This is 1 to 2, so that's good. And then if I keep going around, A to E was 3 to 2. This is 3 to 2, so that one's good. You probably do this a lot faster than I can, right? Here's 1 to 3. This one is 1 to 3. This length is 3 units long, 3 units long, so that's good. And then this ratio is 1 to 4, and this ratio is 1 to 4. So because all the ratios between the points are the same, all the side lengths are the same, and all the angles are the same. And so, yes, these two are congruent. Yes. They are congruent. Oops, sorry. They are congruent. Since they are congruent, I need to describe the composition. How do I go from here to here, right? So the first thing that I see is that this is flipped, right? My short side, I want it down here on the bottom. So to me, I think I can reflect this over the line x, oh, sorry, not x equals, excuse me, reflect over the line. Here's my pen, there we go. Y equals 0, which is that horizontal, right, the x-axis. So if I do that, I get this 1, 2, 3, 4, here. Am I off by 1? What's happening? Oh, and then here. Right, there it is. So now I have this shape. Okay? And so then I can combine it with a translation where I just move it to the left. And I'm going to move it to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So now I'm going to translate to the left 10 and up and down 0. Is that the only way to do it? No, not at all, right? There's tons of other ways that you can write the composition. But for me, that's what I saw first. And as I even look at my notes, I did it differently last year, just because there's so many different options going on, okay? So then I just took this point and I slid it so that it matched up here. So that was left 10 units, and that was up 0 units, or down 0 units. Okay? We're going to try this one more time. Here, I want you guys to give this a go. Is A, B, C, D, E congruent to A prime, B prime, C prime, D prime, E prime? If it is, write the composition. How do you go from the orange to the blue? If it's not, tell me why. So go ahead and hit pause on the video. I really want you to try it, think about it, and then when you are ready to review it, you can go ahead and hit play. All right, so hopefully when you counted the side lengths and counted the ratio, you saw that these are congruent. So yes, they are congruent. So then just the next thing that we need to look at is, how do I go from the orange to the blue? And again, there are so many different ways that you could do this, okay? But I see personally a reflection over the y-axis, which is the line x equals 0. So that moves these points here. So then it becomes like this. Okay, so that's the reflection over the line x equals 0. And then all I have to do is just slide that down. Where I write, I want this point to go to E. So I go down 1, 2, 3, 4, 5. So I'm going to translate it. I don't need to translate it left or right, so that becomes a 0. And I need to move it down 5, so that becomes -5. And that's it. Are there other ways that you could have done it? Yes. Okay, there's a lot of other ways. So, you know, if you're not sure, you want me to check your work or anything like that, just let me know. Send me pictures or things like that. But there are a lot of ways to do this. This is just one way that I saw it. Okay, so let me know if we're needing help with this. Reach out, let your teacher know. We're more than happy to help you. But we're going to move on here to example 4 now, which is just determining are two shapes congruent. Okay, so these first 3, it says, are the pair of objects congruent? If they are, describe a composition of rigid motions that maps one onto the other. Okay, so scroll down so we can see a little bit better here. Perfect. Okay, so for A, here I see that the shapes are congruent, right? They are the same shape. So yes, they are congruent. And I see that if I reflect it over that vertical line, let's call that A, right? A reflection over line A would be my my rigid motion. That would get this shape onto this shape. Okay. For B, this piece of wood is too thick. This piece of wood is thinner. So these are not congruent, right? They are not the same image. Okay, and then C is a little bit tricky. So if we look at C, sometimes it takes a little while for us to look at this. But yes, these are congruent. Okay. And so what we can do is we can rotate 90 degrees. And excuse me, I just wrote that wrong, right? We can rotate negative 90 degrees because I want it to go clockwise, right? And so remember that it's negative if it goes clockwise. So I'm going to rotate it negative 90 degrees. That would put the red square, just to show you, that would put that red rectangle here. And then I guess it's longer than that, isn't it? Like that. And then this would be the blue rectangle here. Just to show you how I went from here to here, okay? So there's not quite lined up, but it's close. The last thing I would have to do is reflect over a vertical line. And if I reflect over a vertical line, and more specifically, if I draw that line here, and I reflect, now it's going to go ahead and match up, where the red is going to be on the left, the teal greenish color is going to be on the right, right, and everything will line up nicely. So I want you to try these two, A and B. So tell me, are they congruent? If they are, tell me what I have to do to map one onto the other. And if it's not, just write they're not congruent. Go ahead and hit pause, try it, and then when you're ready, hit play. Okay, so let's look at these. Hopefully we saw that these two shapes here are congruent. Yes, they are congruent. And all I have to do is rotate this either 90 degrees or negative 90 degrees. Doesn't matter. So I'm just going to go ahead and say rotate 90 degrees. Right? If I rotate it 90 degrees and I translate it, meaning I slide it, right? Because if I rotate it 90 degrees, it's still over here doing this thing. This is my really quick drawing. Oh, that's not what it is it? It's this. Whatever. And then I have to slide it over. For the second one, these are not congruent. There's no way that this makes an F and this does. So this is not congruent. Those shapes are not the same. Good job if you got those. We have one more example to do, and then we're going to be done with this lesson. I know it was a little bit on the longer side. So example 5 says, a boat builder plans to connect two pieces of wood by using a puzzle joint as shown. So here's the puzzle joint. Okay, so it fits together and it allows, obviously, the pieces of the wood not to move or shift. Okay. For a successful joint, each unit must be congruent, right? They have to fit into each other perfectly every single time. Otherwise, the joint's not going to work. So it says, given unit A, here's unit A. Okay, there's unit A. Probably could have drawn it better, but that's okay. What composition of rigid motions maps A onto B? So I just want to know, how do I get A to go to B? And here's B, right? So boom. And hopefully we just see they're the same shape. A is just shifted down, right? So I can just translate down. If I just literally slide A down, it should line back up with B, and it does, right? So do you see how I can translate that shape? So it should just be a translation, and it is. Okay. So then the last question for you guys is asking, is unit C congruent to unit A? And if it is, describe the composition of rigid motions that maps A to C. How do I go from A to C? Okay, so it's asking me, is this unit, my tracing skills are subpar today, right? Is this unit the same as this unit? And if it is, you're going to write and it says describe. So if you want to just describe it in words, that's fine too. But you're going to describe the composition of rigid motions. Okay, so now that you've tried it, let's go ahead and look. So the first of all thing I see is yes, these two units have to be the same. In order for all these pieces to fit together, every single unit has to be the same. So unit A, we can say, is congruent to unit B. Okay, so now that I know that, it says describe the composition of rigid motions that maps A onto B. So the first thing that I see is that A needs to be rotated 180 degrees, right? I need all of this to be facing downward. So I would first of all rotate A 180 degrees. Okay, and then it's probably not going to line up perfectly onto C when I rotate 180 degrees. So then I'll probably have to translate as well. Right, I'll probably have to slide it into the correct position. So rotate it and then slide it down. Okay, so that's it for 4-1 today. If you have any questions, please reach out. I know that was kind of a lot, but we have talked about transformations before, so hopefully you're feeling okay. If not, reach out, let us know. We're happy to help you, and we will do 4-2 next time.